This lesson's entitled Angle Bisectors. Remember, bisectors are things that cut things in half into equal pieces. So an angle bisector cuts an angle into two equal angles. We'll be seeing how we use that information in angle bisectors. I will be able to formulate the test conjectures concerning angle bisectors in angles and within triangles. So let's look at our first part here, some descriptions. So we've got this angle right here and the angle bisector in this picture. We can tell because both of these angles are congruent. If it bisects it, then these two pieces are equal, and they put the congruent marks in there. Then it says if a point is on an angle bisector, so here's this point S is on this angle bisector PS, then the point is equidistant from the sides of the angle. Okay, so the distance from that side, this side of the angle right here, is AS, and the distance from this side of the angle is BS, and it's saying those two distances will be equal. So it looks like this. If you know that in this picture down here, AB is an angle bisector, if they tell you or if they mark the angles congruent, this one equal to this one, then in this type of picture we know that this piece is equal to this piece. These distances are the same. Okay? That's what this first one's saying. If we know it's an angle bisector, either they tell us it's an angle bisector or they mark these two little angles congruent, then we can mark these pieces congruent. The second part is just the opposite. If I get rid of this and it says if a point is on the interior of an angle and is equidistant from the sides. So that's this type of picture. We're showing that these distances are equal with these congruent marks here. Then what we can we say? Well, then we can say the angles are equal and that this is in fact an angle bisector. So if the sides, these sides right here, or these pieces right here, these distances, if they're marked, we can go ahead and mark the angles. We know that, okay, those are the same. So there's two types of problems you'll see. We'll have an angle, or even a triangle with an angle bisector in it, and then these distances in there. And if we know that these angles are congruent, then we also know the side, these pieces are congruent, or vice versa. If we know these pieces are congruent, then we know the angles are congruent. That's all there is to it. If you've got one, you can say the other. So let's look at some examples. Here's the first one, example 1. It says PS, this segment right here, this line or this ray right here, is an angle bisector of angle APB. So since they tell us it's an angle bisector, I can mark the angles. And we learned that, okay, if these angles are congruent, then these distances are also congruent. So AS, that distance is congruent to what? BS for your notes. And then conversely, if we start off knowing that, no, we don't know it's an angle bisector, but if we know these pieces, AS and BS, are congruent in the second part, then we also know that this is an angle bisector, and we could mark the angles if they weren't already marked. Okay, either way. If you know the angles are these pieces are equal, then these distances are equal. If you know the distances are equal, then the angles are equal. It is an angle bisector. Here's some of the problems we'll be doing, of course, with our thing. This example, I'm going pretty fast because I got to finish this. Here, in this picture, I've got the angles marked. So that is an angle bisector there. So I can mark the pieces. Yes, this distance is equal to this distance. And to solve for x and find these lengths, we know these two are equal. That's our equation. This one equals that one. And so we go ahead and solve it real quick. I subtracted x from both sides. If I go too fast, just pause it. Once we do that, we get x minus 7 over here and equals 5. So I'll get rid of that minus 7 with plus 7. And I get x equals 12. So that's that answer. Then they want to know this distance jk. So jk in the picture is x plus 5. So we substitute the 12 in for x. We just found it. So 12 plus 5 is 17. Now the other one should be equal to it, but I'll go ahead and double check. It should also be 17, but let's go ahead and do the work. So Jm here is 2x minus 7. X is 12, we just found it. So 2 times x, or 2 times 12 minus 7, yes, is 17. Okay, next example. Here again, we've got the angles marked congruent. So first thing I do is remind myself that these distances from this angle bisector are equal also. So there's our equation. 5y equals 3y plus 6. Subtract 3y from both sides. I get 2y equals 6. Divide by 2. And I get y equals 3. So there's our first part, y equals 3. So then st right here is 5 times y. And our y is 3. We substitute that in there. 5 times 3 is 15. The other one should come out congruent if we've done the right stuff. So I'll go ahead and do it. Let's see, tu is 3y plus 6. So 3 times the y number was 3 there, plus 6 is 15 also. So that's all there is to it. If the angles are congruent, then these distances are congruent, or vice versa. In this picture, we've got these distances are equal. So, since they're marked, I know these angles are equal. This one equals that one. So now we're setting the angles equal to each other here, because that's where our variable's at. So the 3a plus 20 angle equals the 2a plus 26. So we'll go ahead and solve that real quick. I subtract 2a from both sides. I don't want a's on both sides. So 3a's minus 2 leaves me 1a, or a. And plus 20 equals 26. So now I'll get rid of this plus 20 and get a by itself with minus 20 there. So a equals 6. Then they wanted the measure of MKL, which is this piece. Sometimes they want the whole thing, so you just take one piece and they're equal and double it. But here they wanted the one little half over here, which is 2a plus 26. So a is 6, we'll substitute it in there, so we'll have 2 times 6 plus 26, which is 38. So both these angles should be 38, and you know, if you want the whole thing, you add them up, 38 and 38, or times 2, and you can get 76 there. Alright, so here are the practice problems you're going to do now, so I'm going to stop this video and let you do your practice problems.